Hello everyone, I am Akshata D Wadgaonkar, working as Assistant Professor at Walchand Institute of Technology, Solapur. These are the learning outcomes. At the end of this session, student will be able to learn step used to perform convolution sums. These are the content. First of all, I am going to discuss about introduction to convolution, then what are the steps used to perform convolution sum, and that I am going to take one example based on this convolution sum. So now let us understand what is convolution. Convolution is a mathematical operation used to combine two signals to produce third signal, which is y of t equal to x of t into h of t. Convolution is widely used in signal processing to determine the output of system given its input and impulse response. Mathematical formula to calculate convolution sum is y of n, which is equal to summation of k equal to minus infinity to plus infinity x of k h of n minus k. Now let us define the step, or let us discuss the step used to perform convolution sum. First step is we have to define the functions here. Convolution process involves the two signal, that is input signal or excitation signal of x of n having length m. Second is impulse response signal having length n. Then we have to convert the n into k, that means we just have to change the variable n by k. Then we can visualize the impulse response h of k as a function of index k. This is help to clearly see the shape and range of impulse response. Similarly, plot the input signal x of k as a function of k, and this allow you to identify the value and now let us decide step number 2, that is we have to calculate the length of output sequence. If the length of output sequence is calculated by using formula L equal to m plus n minus 1, where m is nothing but length of x of k and n is nothing but length of h of k. For example, if x of k is given having length 4 point and h of k having length n equal to 3 sample points, then how we can calculate the length of output sequence L equal to 4 plus 3 minus 1, which is nothing but 6. Now let us define the third step, which nothing but we have to fold or reverse the impulse response. We have to reflect the h of k across k axis and to get the value of h of minus k. This flip the impulse response function in time. Step number 4 is we have to shift the folded function. Next we have to shift the folded function h of minus k by n to get the value of h of n minus k. This shifting allows us to move along h minus k along x of k axis. Step number 5, we have to multiply the signal. Here we have to pointwise multiply the input x of k and shifted impulse response h of n minus k. Step number 6 is we have to perform here sum the products. That means we have to calculate the sum of products of all values of k by using formula y of n equal to summation of k equal to minus infinity to plus infinity x of k h of n minus k. This provides the convolution output at each values of n. Step number 6 is we have to repeat it for all the values of n. That means we have to repeat the process for all value of n and we have to plot y of n, which is the convolution result. Now these are the summary of all steps. That means first of all we have to convert n into k for x of n and h of k. Then we have to calculate the length of output sequence. Then we have to flip the impulse response. Then in step number 4 we have to shift the flipped input response step. In step number 5 we have to multiply the signals, and in step number 6 we have to perform the sum of product using convolution sum formula, and in step number 7 we have to repeat it for all the values of n, and at last we have to plot our resultant signal. Now let us take one example based on this convolution sum. Now this is our example where x of n and h of n given sequence is given, and we have to perform here convolution sum. So our step number first is we have to just convert our n by variable k. That means we just have to change here variable. We have to convert the variable x of n by x of k, and then we have to plot our given signal. So it is started from 0, 1, 2. At 0 amplitude is 1, at 1 our amplitude is 2, at 2 amplitude of signal is 3, and our next signal is h of k. That means we just change the variable n by k, and then we have to plot our signal. So 0, 1, 2. At 0 our amplitude is 1, at 1 amplitude is 2, and again at 2 amplitude is 2. So this is our given two input signal x of k and h of k, and here we just change the variable n by k. Now our step number 2 is that we have to calculate the length of y of n. How we can calculate? First of all, we have to calculate the length of x of n. We have to calculate length of x of n, which is equal to 3, then length of our h of n, which is again equal to 3, then length of our output y of n, which is equal to 3 plus 3 minus 1, which is nothing but 5. So output sequence having length which is equal to 5. At the same time, we have to calculate lower range of y of n. So how to calculate lower range of y of n, which is nothing but lower range of our x of n plus h of n, that is nothing but 0 plus 0. That means our y of n is started from 0, and then we have to find out its upper range. Next we have to find out upper range of y of n, which is nothing but 2 plus 2, which is equal to 4. So our y of n is having total 5 sequence, which is started from 0 to 4. So in step number 2 we calculate the length of output y of n. Now in step number 3 we have to flip the h of k, and we have to plot the sketch of h of minus k. So how it is? Just our time axis is get changes, plus 1 become minus 1 and plus 2 become minus 2, amplitude remain same. So here it is 1, 2, 2. Okay, this is the our signal of h of minus k plot. Now in step number 4 we have to perform shifting operation. That is, we have to perform h of n minus k. Now we have to take here different values of n from 0 to 4. So check the first condition. When n equal to 0, we have to perform here convolution sum. So when n equal to 0, x of k is as it is, okay, and h of n minus k means h of 0 minus k, it is become h of minus k, and we have to perform here output convolution sum. So k equal to minus infinity to plus infinity, y of n equal to x of k into h of minus k. Okay, so what we have to do? We just have to perform here convolution sum formula. So keep x of k as it is. So it is 0, 1, 2, amplitude is 1, here it is 2, here it is 3. Now h of minus k. So we have to plot h of minus k as it is here. Minus 2, minus 1, 0. So amplitude is what? 2, 2, and for 0 it is 1. Now what we have to find out? Y of n at n equal to 0. So see, when at 0 amplitude is 1 here, and at 0 amplitude is again 1 here. At minus 1 amplitude is 2 here, but here it is 0. Again at minus 2 amplitude is 2 in h of minus k, but in case of x of k it is 0. So again we have to add 0, so no value. Again when it is at plus 1 amplitude is 2 in x of k, but when it is at 1 amplitude is 0 in h of minus k. When our time is at 2 amplitude is 3 in x of k, but amplitude is 0 in h of minus k. So what is our output? Y of n equal to 1 into 1, that means equal to 1. Now we have to calculate the second value, that means for n equal to 1. Now what happen? Our y of n, which is equal to summation of k equal to minus infinity to plus infinity x of k as it is h of 1 minus k. Now see what happen? Our x of k is again as it is 0, 1, 2. At 0 amplitude is 1, then at 1 amplitude is 2, at 2 amplitude is 3. It is multiplied with h of 1 minus k. So this is h of minus k, and when it is add 1, our signal is shifted toward right hand side, and we can start our signal from minus 1, 0 to 1, and amplitude remains same, 2, 2, and here it is 1. Now y of n is what? At 0 here it is 1, and here it is 2, 0 into 2 plus here it is 2 into 1. So our output is what? 4. So y of what it is? Y of 1 equal to 4. Now we have to calculate third value when n equal to 2. So for n equal to 2, what happen? Our y of n or y of 2 is equal to what here? Summation of k equal to minus infinity to plus infinity x of k h of 2 minus k. So again our x of k is as it is 0, 1, 2, amplitude is same, 1, 2, 3 is multiplied with h of 2 minus k. So h of 2 minus k means signal is shifted to right hand side by 2. So it is 1, 2. Signal is started from now 0, 1, 2. So amplitude is same. It is 2, 2, 1. Now y of 2 is what here? 1 into 2 plus 2 into 2 plus 3 into 1. So how much it is? 2 plus 4 plus 3, that is equal to 9. So y of 2 is equal to 9 here. Okay, y of 2 is 9. Now calculate for y of 3. So here we can calculate our next step for n equal to 3. So y of 3, which is equal to summation of k equal to minus infinity to plus infinity x of k h of 3 minus k. So we have to plot x of k as it is, and h of 3 minus k is started from now 1. So x of k means it is 0, 1, 2, amplitude is 1, 2, here it is 3, is multiplied with at h of 3 minus k. So it is 1, 2, 3, amplitude is 2, 2, and here it is 1. So y of 3, which is equal to, for 1 amplitude is 2 into 2 plus next amplitude is 3 into 2 and plus 0. That means we have to take only this value. So y of 3, which is equal to 4 plus 6, which is nothing but 10. Now we have to calculate our next and last value, that is fourth condition, when n equal to 5. So y of 5, which is equal to summation of k equal to minus infinity to plus infinity x of k h of 5 minus k. So our next value is y of 5, which is equal to x of k is as it is 0, 1, 2, amplitude is 1, 2 and 3, and h of 5 minus k, that means our signal is started from now 2. So 2, 3 and 4. So at 2 amplitude is 2, at 3 amplitude is 2 again, and at 4 amplitude is 1. So again what we have to take? We have to calculate the values here. So what is our y of 5 now? Y of 5, which is nothing but at 2 it is amplitude is 3, and at 2 here amplitude is 2, and otherwise it is 0. So y of 5, which is equal to 6. So our total y of n that we have calculated is having the value of 1, then 4, 9, 10, 6. This is the value of final output y of n, 1, 4, 9 and 10 and 6. These are the steps used to perform convolution sum. I hope everyone should understand. These are the references that I have taken. Now I hope everyone should understand how we can perform convolution sum and its formula, and how we can calculate by using signals. So thank you so much.